Didn't see you there. I was just getting a drink of water. What's that? You want to hear about what I did this summer? Sure, come with me in my office. Hi, my name is Wong, and I'm a rising senior at Whitney Young High School. This summer I worked with Professor Raul Castro Ferandez on a database generation project called dgen. But before we talk about dgen, let's talk about relational databases. Relational databases are a popular way to store related data into tables and columns. You can place constraints on columns such as unique or not null constraints, and you can create relationships between data in different tables. In this diagram, the mentor name column in the students table is related to the mentor name column in the mentors table. These constraints and relationships give databases integrity and make them a versatile and reliable method for storing data. Since relational databases are so common, searches and queries on databases need to be fast, but this can be hard to achieve. Most queries require specific database schemas to even run. They require that databases have tables and columns with specific names, data types, and relationships. It's almost impossible to find other databases with the exact same schema that you need, especially if your query is very niche. Additionally, benchmarking the speed of queries requires databases of various sizes and data types. For example, a query might run fast on a small database with positive integers, but how about on a larger database, or on negative integers? Additionally, the larger the database, the more inconvenient it is to download or distribute, especially if working with others. This summer I built dgen, a robust tool that aims to solve these problems by generating various random data that adheres to user-defined database schemas. To achieve this, a user first writes a high-level specification describing their relational database. Users can write their specification from both general or defined scopes. Users can say something very broad, like just give me 50 tables, or they can say something very specific, like I want a table with a column with integers, a column with strings following this regex pattern, and a column with floats following a Gaussian distribution. Users can specify other aspects of relational databases, such as constraints, intercolumn relationships, and intertable relationships. Allowing users to specify so many things from various scopes was incredibly difficult to implement, but as a result, dgen is more adaptable to the needs of users. After a user writes their high-level specification, dgen then translates it into a low-level specification. Low-level specifications remove all of the vagueness of the high-level spec and fill in any missing information the user didn't provide. For example, if a high-level spec asks for 50 tables, dgen will determine the number of rows for each table, the number of columns, the data types of each column, and the ranges of those data types. dgen then takes the low-level spec and creates data generators using Java that are then used to generate the database. dgen utilizes random seeds in the low-level spec to ensure that all databases can be reproduced given the low-level spec and the random seeds. Finally, that database is serialized into standard database forms such as CSV, Postgres, and Parquet so that they can be queried by users. This summer, I implemented this workflow into a working end-to-end prototype of dgen. I learned a lot about project design and project planning. In the future, I would like to expand on dgen by optimizing its scalability and making it easier for database users to extend dgen's capabilities. So, that's what I did this summer. I'd like to give a shout out to Raul, Katie, Kyle, and the lab coordinators for making this an awesome summer. And as always, thanks for watching.